Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Marylou.
And in studio with us we have another M, Mary. And Mary, if somebody needed to get a hold of us, what would they need to do?
For math help, call in Bakersfield 636-4357. Anywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. Thank you for that, Mary. Why don't you let everybody know where you go to school and what grade you're in?
So I go to William B. Bimat Elementary School, and I'm in 6th grade.
And have you been at Bimat for a long time?
Yes, I've been there since kindergarten.
Since kindergarten?
Mm-hmm.
All right, so you're pretty used to the place.
Yeah.
What do you look forward to when you go to junior high next year?
Like the math over there.
Well, it doesn't,
like
anything
math.
at all. Are you looking forward to the math classes? I don't know.
I like
could
math
be.
and science.
Oh, good. So you like math and science. Those are two very key topics that are going to serve you well if you, first of all, have an enthusiasm for math and science. What's something you think you'll miss from BMAT after being there for 7 years?
Like my teachers and like the principal.
Okay. So he or she's a pretty nice person?
Yeah.
Get along with them all right? No difficulty?
No.
All right, good. That's what we like to hear. You ready to do some math today?
Yes.
All right. Well, before we actually have you start doing some math, I have some questions for you.
Yes.
All right. Do you own a lot of stocks and bonds?
I don't know what that is.
No, you're like, I don't know what you're talking about, old man. No, stocks and bonds. I don't need stocks and bonds, right? Have you ever heard of stocks, like the stock market and things like that?
Oh, yes, I
Okay,
heard
good.
of
All right.
that.
Well, so now we're on our way. So what do you know about the stock market and stocks? Kind of anything in general right now, or you just heard of the terms?
I've heard of the terms.
Okay. So if you own a company, all right, let's say Mary Lou owns a company and she sells running shoes, okay? And she wants to get more money, so she wants to have investors, like you and me, invest in her company, all right? So we give her money to expand her store, all right, so she can make new things and get bigger.
Okay.
And by us doing that, we get shares of her company, all right? So we actually have like a little tiny bit of her company. Does that make sense so far?
It makes sense.
So you get shares of stocks, all right? And you can buy them for certain prices, right? Like let's say you and I, we buy it and it costs us $5 for one of these, okay?
Okay.
And a lot of other people do it also. And in a year from now, somebody goes, hey, I heard about those shoes that Mary Lou makes. That company's doing pretty well. I want to get in on that, right? And we're like, all right, well, go ahead and check it out, right? And Mary Lou goes, well, when I sold it to Mary and Mike a year ago, it was $5. Now it's $15. So the price went up. Ching, ching, baby. You hear that? Okay. So by us investing, we've made money now, haven't we?
Yeah.
And we didn't have to do anything.
Yeah.
Except let her use our money for a little while.
Yeah.
That make sense?
Yeah.
All right. So that's what stocks are. And bonds kind of work almost in the same way. Have you ever heard of cryptocurrency or Bitcoin?
Yeah.
Where have you heard that?
I've heard of it like on the internet, I guess.
Okay, but that's probably where you're going to hear it. And that leads us to today's Math in the News. All right, so we can take a look at the graphic that I've got right here. This is just a photo of Bitcoin. All right, do you remember, have you ever seen that?
Yeah, I think so.
Okay, so if you do go online and you look up Bitcoin, you're going to see an image similar to that, all right? And it's cryptocurrency, where you don't actually hold anything in your hand. You're letting somebody else use your money to make money on what you have given them. Are you following it, kind of?
Yeah.
I know it's kind of hard, because you're like, well, what do you mean? I'm not even giving them money, and they're holding money, and it's like in the air and stuff like that. But there are a lot of people investing in cryptocurrencies now. And a lot of times there are people, and John and I were speaking about this before we went on, that there are some people that bought cryptocurrency years and years and years ago. I think you could buy a Bitcoin for $55,000 now. Well, years ago when this first came out, you could probably buy it for $5, okay? And people just held on to it. So it's worth a lot of money. But at the time, you were only able to hold it in the computer that you bought it on. All right, now they have these crypto wallets, which are a little better, okay? But it's my understanding, not that I know everything about this, but you used to have to be able to take it off the computer that you purchased it on, okay? We know there's a lot of passwords in our lives, right? Okay? And if you don't remember your password to get into that account again, you're not able to get that back.
Well, that doesn't sound good.
That doesn't help anything at all, right? That's not a good thing. But that's how it used to be. Okay, and I'm sure there still are instances where that is the case. But the crypto wallets now are something that makes it a little easier, where you don't have to remember these passwords all the time, and it's not dependent on what computer you're on, things like that. So sometimes people, we do a stock market game in class. And it's to kind of help get the kids used to when they are out on their own and using money and how to value money, okay?
Okay.
And they take a look at stocks in the stock market and how they can grow money. And they always want to know, well, how much should I put into cryptocurrencies and Bitcoins? Because that's a big thing now. How much money should I put into that? Well, from the experts, here's what you should do, all right? You should have about 47% of your money in stocks, about 52% of it in bonds, and about 0.5% in cryptocurrencies, all right? So it's good to have some, but they're saying you should not be putting a whole ton of money into it, like selling all of your stocks and putting it all into cryptocurrency. If you have a lot of confidence that cryptocurrencies will continue to rise and just keep on going like that, I think they said you really don't want any more than 7 to 10% of your portfolio in cryptocurrencies, right? So hopefully you kind of follow that a little bit. But that was something in the news about how much of your money should be allocated to different parts of whatever monies you do have, and you have money to invest in things like that. And that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30. We do most Tuesdays and Wednesdays throughout the regular school year. But big programming note here, young ladies, because this is the second to last week of live programming for Do the Math this year. So today is the 16th of March. Next Wednesday will be the final day. The 24th will be our last live broadcast for this year until we come back again at the beginning of the school year next year, and we begin season 2021. 21. So
wow.
We've been doing this for a long time. There's a wonder I'd look a little different after that amount of time. Anyway, we do have Mary in studio with us. We have Marylou in studio with us. We have 3 M's up here, and we're going to discuss the 3 M's, mean, median, and mode today.
Yes, we are.
All right?
Okay.
So we're going to take a look at one of the problems you have in your book, and this is the next lesson you're going to, isn't it?
Yeah.
All right, so let's take a look at this right now, see if we can help you out, get ready for school, for what is coming up in your next lesson. All right? So, Marylou, did you want to discuss some of the terms up there first before we go?
Yes.
All right, go ahead.
Let's go ahead and do that. Now, Mary, I put 3 vocabulary words up there. Before we get started, just making sure that we know what these mean as we talk about them. Can you tell everybody what the word mean is? What's the definition of mean?
So mean means that it's like the average of a group of numbers that you have in like in a data table.
And how would
Or-
you figure that out? How would you find the mean?
So what you would do is that you add all the like pieces of data that you have and then divide it by the number of how many pieces of data you have.
Very good. And so you already said it, average is the mean, correct? They go side by side.
Yeah.
Now, what about absolute value? Have you heard that before?
I think so. Yeah, I think I've heard of it before, but I don't remember what it means.
Absolute value is how far away is a number from zero. So even if we have a negative number, we say, what is the absolute value? And the absolute value is normally positive because we're talking about how far away from zero is it.
Okay.
So if we do real quick, a quick number line, and I have -1, I'm just going to go -2, and I say, what's the absolute value of -2? What would the absolute value be?
That would be 2.
Exactly, because we know that -2 is 2 places away from 0.
Zero, yeah.
So that is something that we're going to need to know with as we move on. Okay.
Okay.
So we are doing what we're finding the MAD, which is in other words, is the mean of, help me out, Mike.
Absolute deviation.
Absolute deviation. The mean
right.
of absolute deviation, which is also called the MAD. Okay.
Okay.
To find that out, I think, Mike, you have a set of number for us,
Right,
correct?
so we're going to go ahead and do this first one that she's
Okay.
got coming up. So here we go,
New
the
page.
known moons of planets. All right,
Okay.
0,
You want to go ahead and write those numbers
Oh.
up at the top?
Okay. Oh, oops.
There you go.
another 0, 1, 2. And before we keep going, Mary, do me a favor, just put a comma between each of the
Oh,
numbers
right.
so that we know that maybe that's not 12 or something. All right, here we go. Let's take a look at the next row. 63, 34, 27. Oh, did you want to fix your 34? All right.
Yeah.
All right, so after 34 is 27, and then 13. And round to the nearest hundredth if necessary.
Okay.
Okay.
So the first thing we want to do when we're finding the MAD is we want to find the mean of the data set. So find the mean of this data set.
Okay.
So walk me through what your thinking is.
Okay. So I was gonna add all the numbers first. So 1 and 2 is 3, and then you're gonna take 63 plus 3 from over here, and you add it, and you get 66, and then you take 66 plus 34, and you get 100, and then you add that to 27, and then you take 127 and add it to 13. That's 140.
All right. So what are we going to do with the 140? Is that our mean?
No, then you take the 140, I'm gonna go over here, and divide it by 1, 2, 3, 4, 5, 6, 7, 8, 8, because that's how many numbers we have.
And remember, we're rounding it, I believe, to the hundredths.
Yes. So first you divide 8 into 14, it goes in once, then you subtract that and you get 6, bring down the 0, then 8 goes into 60 7 times, because 7 times 8 is 56, then you subtract, you get 4, and then put a decimal, bring down a 0, and then you have to put a decimal there, and then 8 goes into 40 5 times, and then 40 is 0.
And we're done, right?
Yes.
Okay, so up at the top, right, mean equals 17 and 5/10.
Mean 17.
Okay, So I want you just to erase your work, leave all of the data set, just erase your work for me, okay?
Okay.
So now what we're going to do is this. What we need to do is find the MAD. We need to find the absolute value of the difference from each number to the mean. Okay? So what is the absolute value distance from 0? So let's write these numbers out this way. We have 0 and 0. We have our 1 and 2. And I'm going to let you finish writing those numbers.
Okay, 63, 34, 27, and 13.
Okay, so we need to find the difference from each number to 17 and 5/10.
Yeah. So how do you find the difference? Is that you take 17.5,
Right?
and then you subtract each one from it, and then you'll find the difference. So minus 0 equals 17.5.
On some of these, though, you can mentally do that, right?
Yeah.
So on the 0 and the 0, we already know that they're both going to be 17 and
17, yeah.
and 5/10.
Yeah.
So let's go ahead and write those off to the left side of it
Okay, so
on by each one. So we know that's 17.
and then 17.5.
And mental math this, what do you think the
Yes.
next one's going to be?
The next one's going to be 17.4.
Is it 17.4? Remember, that's a whole 1.
Oh, oops, I thought it was a 0.1. Then it will be 16.5.
Got it.
And then this one will be 15.5.
Now, the other ones you're going to need to do some work, aren't you? Okay,
Yeah.
so you can go over here and do that work.
Okay, so 17.5, and then subtract.
Are we going to do the 17.5 on the bottom or the top?
Oh, the bottom.
Yeah, because remember, we're finding the absolute value.
Oh, yeah, okay. So 63, I'm going to put 2 zeros so it can help with placeholders. 17.5, and then 0, 0, or no.
Oh, there you
Sorry.
go.
Yeah. Okay. So this we'll have to borrow. Make that 10. Make this 2. 10 minus 5 is 5. Put your decimal. 2 minus 7 you have to borrow. And then this make it 5. And then 12 minus 7 is 5. 5 minus 1 is 4. Oh, let me fix that.
Okay, so that's our next one, 45, and you can just put 45 and 5/10. So when
Okay.
you go to do that, you don't need the hundredths 0. Let's just leave the tenths 0, okay,
Okay.
for placeholder.
Yeah, okay. So the next one is, I'll write it right here. 34, subtract 17.5. You'll have to borrow, make that a 10, make this a 3. 10 minus 5 is 5. 3 minus, then you have to turn this 3 into 13, this into 2. 13 minus 7 is 6. 2 minus 1 is 1.
Okay,
And that's 16.5. Then the next one is,
27.
27. Minus 17.5.
Now, before you do that, stop for a second, Mary.
Okay.
What's 27 minus 17?
27 minus 17 is 10.
Okay, but we have a 0.5, so it's not going to be 10.5, so we're going to take a 0.5 away from 10.
Okay.
Which is?
And what is that?
And that is 9 point,
Yeah, you got it.
yeah, 9.95?
No.
Oh, wait.
9.5.
9.5.
There you go. That's
there-
your answer.
That way you can just kind of
Yep.
think about this a little bit.
So let's count backwards for 13.
Right, do the same thing for 13 now.
Okay,
So how far is 13 from 17?
it's 4.
4, but we have that 0.5.
So it's going to be 3.5.
Is it 3.5 or 4.5?
3.5.
Think about this. We have 13 to 17, which is 4.
Okay.
In addition, another 0.5. So we're actually adding.
Oh, 0.5. So it's supposed to be 4.5.
Got it. Okay, now we have all of our absolute values, right?
Yeah.
So we found our mean. Now we found the absolute value of all of the data, okay? From the mean. So now our last step is to add all those up.
Yeah.
All right. So can we do a quick calc, because you have them lined up really nicely right there. So I'm going to do this real quick. Hold on. Let me move this up a little bit. There we go.
Okay.
So Mary, what we're going to do is let's quickly kind of do some mental math. So we have, count with me by fives.
5, 10, 15, 20, 25, 30, 35, 40.
There you go. Right?
Yeah.
Carry the 4 up there. And let's see if you could add this up.
Okay, so 4 and 7 is 11, and then plus 7 is 18. 18 plus 6 is,
24?
yeah, 24. And then 24 plus 5 is 29, and then 29 plus 5 is
34.
34, yeah. And then 34 plus 6 is 40, and then 40 plus 9 is 49, and then 49 plus 4 is,
53?
yeah, 53.
Okay, put your 3 and carry your 5. There you go.
And then 5 plus 1 is 6, plus 1 is 7, 8, 9, and then 9 plus 4 is 13. 14 plus 9.
Wait, no. That's it. That's
Oh.
it. 14. So bring down your 1 and your 4, because the 9, remember, is in the ones column.
Oh, yeah, right. I forgot.
So bring down your 14. There you go. So all of that totaled 143. And how many numbers did we have in the data set again?
We had 8.
Okay, so what do we need to divide 143 by?
8.
Okay, divide it by 8.
So 140.
Oh,
wait, let me-
143 goes in the house.
Oh, yeah, right. I forgot. 143. And then 8. And then 8 goes into 14. Once subtract that, you get 6. Bring down the 3. 8 goes into 63. 7 times. Yeah, 7 times. And then 7 times 8 is 56. Subtract, you get, bring down,
Yep, that's
5,
right.
yeah. And then this becomes a 13. 13 minus 6 is
7?
7, yeah. And then bring down a 0, put a decimal. 70. 8 goes into 70. 7 times, put the decimal. Can you scoot it
Oh
up?
yeah, there you go.
Okay. 70 minus 56
You
equals.
think you could get any closer?
Oh.
Yeah, can we get closer than 7? What about 8? Instead of
Oh,
7, can
8,
no,
yeah.
leave the 70 there.
Oh.
Let's leave the 70 there, erase the 56.
Oh, right. Okay.
Oh no, right here. Here, let me help you out. Hold on. We want to keep that there.
Oh,
this,
okay.
Get rid of that.
Okay.
And yeah, and the 5. There you go. And let's change that 7 up top to an 8.
And then 8, and that equals 64. Subtract, you get 6. Oh, that looks like a 0.
And I think that that's, yeah. And bring down your 0,
And then another 0.
because we got to go to the hundreds.
Yeah, 60 goes into 8.
Are we back at 7?
Yeah, 7. And then 56. Subtract, you get 4.
And we're going to stop there because we needed to round it, right,
Yeah.
to the nearest hundreds, because that's going to be a 40. And if that's a 40, we're going to
gonna
leave
be
it,
5.
right?
Yeah.
We're going to leave it where it is. So, or it's going to be 5. That's right.
Right.
Yeah. Right here. 5. And then 40.
So that's going to round
That's up.
up.
That's going to round up to 17 and 87 or 88?
88.
88. So write that off to the side for me, 17 and 88 hundredths, and circle it.
Oh, okay.
And that is our MAD. So all of that work, okay, let's think about, where did you start first? What did we find first?
I first found the mean.
Right? And then what did we find?
I found the average.
The absolute value?
Yeah, I mean, the absolute value. And then we did it, like,
What did we do once we found the absolute value right here? What did we do with all these numbers?
We added them and then divided them and got that.
There you go. All that work for that.
Wow.
There you
Very
go.
well
Nicely
done.
That's a great problem. And for your great effort, you've got yourself a meal courtesy of our friends at the Broken Yoke. So congratulations on that. Hope you have an opportunity to go enjoy a meal of your liking over there. That's pretty nice, huh? That's a pretty long problem, huh?
Yeah.
All right, well, you know what? We'll give you a breather. We'll be back with more right after this. Well, Olivia, you had a little bit of a taste of what it's like to work at the treatment plant. And on our next stop, Dave, we're now in the lab.
That is correct. So we actually need to know what's in the water, both when it comes into the plant, when it leaves the plant. And we have our own laboratory with a lab analyst do that. So with us is Sandy Minner, and she is a lab analyst with Improvement District number 4.
So what is your role here in the lab?
I am a lab analyst. I've been here for 7 years, and we're jack of all trades in the lab. We have to do sampling, testing, report preparation for the state, and we basically test all of the properties of water that would be important for drinking water, make sure that it's safe for consumers.
So Sandy, what type of degrees or college classes could I take to get into a laboratory career like this?
Well, it's not required, but I have a degree in chemistry. A biology degree would also be helpful. Basically, anyone with a strong interest in math and science would probably be a good fit here.
And I was just outside with Derek testing the water and the whole final process of the distribution stage. But when you get the water in here, what type of analysis do you have to do?
We do things, physical chemistry like pH, alkalinity, total dissolved solids, whether you're going to have a lot of minerals that build up on your sink. We want to minimize that sort of thing. Anything that is hazardous to health, of course, we're testing for regularly. We go out weekly to our distribution system and sample at various points along the distribution system and get samples for both microbiological testing and the physical analyses.
Well, I know in a lab there are a lot of great toys that a lot of people would look at and go, you know what, I really am interested in that, how that works. I know you've got a mass spectrometer that you guys work with and some other instruments. How about we go check those out?
Okay.
All right. Dave, we're at the other end of the lab, and who have we got with us now?
This is Paul Wegner. He's our laboratory supervisor.
We do a number of tests here to make sure that the water that we are treating meets or exceeds federal and state regulations, and we have a number of instruments that we use to accomplish that. Ion chromatograph, and this instrument is used to measure analytes such as chloride, sulfate, nitrate, nitrite, fluoride, things like that. And so those are some of the inorganic anions. And then we have an instrument right here. It's called the atomic absorption spectrometer, and it measures metals. And it has basically 4 different ways of doing that. This particular method would be measuring things like magnesium, manganese, that sort of thing. And a sample is introduced through an aspirator tube. This is just water right now. And you can hear the change in tone there, so you know the sample's going in. This happens to be a calcium carbonate solution, and I'll show you what that looks like when it's introduced into the instrument. Have a nice reddish orange. There are lamps that emit a specific wavelength going over and through the flame. As the sample is introduced, energy is emitted from the electrons in the analyte that we're looking for, and in that way we're able to measure the intensity of the peak. Again, looking at that peak, we're able to use the calibration curve previously put in, and we can get the concentration of our analyte that we're interested in. This particular instrument is used to measure disinfection byproducts, and those are components that are formed when total organic carbon comes into contact with strong oxidants like chlorine. And we also use this instrument to measure pesticides.
With this whole mass spectrometer system, what exactly does it do? I mean, there's a ton of stuff over here.
This is all one instrument right here. from that printer to here. So we have 2 automated samplers. This one introduces volatile organic chemicals. And this one introduces taste and odor compounds. They're both going into the gas chromatograph, and then inside the gas chromatograph we have columns. These particular columns are hollow. All the compounds come in at once. They are hopefully separated and delivered into the mass spec one at a time so we can measure the intensity. And then you will come over here, and the operating system is able to measure both by the mass of a compound and the area of that peak. We're able to quantitate the concentration through a calibration curve that was previously analyzed.
So after looking at this compound table and everything that you have to measure here, what do you find most interesting about working in this lab?
You know, I like the analyses. It's a challenge, especially at the levels that we are measuring. We're looking, I know that sounds kind of odd, but we're looking to see how little we can see, where in some labs, one that I came from, we were concerned about how much we can see, but this is drinking water, so it's very low-level analysis, so it's a challenge because the instrument has to be running very well to get to those lower detection limits.
Over here we have the 1 megawatt facility. Throughout the course of the day, it generates electricity. Over the course of 2014, we generated 1,660,000 kilowatt hours. So treated water actually uses considerably less. We're looking at about 900 kW.
Well, just a reminder, today, tomorrow, and next week, the final 2 weeks of live broadcasting for Do the Math this season until we come back in September. But time now for our museum moment. And today we are lucky enough to have Curtis from the Bakersfield Museum of Art in studio with us. How are you today, Curtis?
I'm doing great. How are you today?
I'm wonderful, thank you. So what will you be doing with Mary today?
Well, I've got a couple of things I want to talk about the museum, first of all, but then we have a really cool project on symmetry and how it kind of relates to both the art as well as the math world. And then go and launch into it. So thank you so much for having me on again. It's always a pleasure to be here. The museum, while unfortunately it is currently closed, we do have some really great digital offerings that we are putting out there. We have 3 brand new exhibitions, and they are available with digital tours on our website, bmoa.org. Now there are 3 current exhibitions. The first one we have is the Bakersfield Sound Exhibition, Roll Out the Red Carpet. Really cool exhibition regarding the musical artists that came up out of Bakersfield, including Merle Haggard, Buck Owens. It has different costuming of theirs, musical instruments, and it's really a tremendous show. So if you do have the opportunity to check that out on the website, I highly encourage it. It's a great historical piece. We also have Color and Figure, which are paintings by Linda Christensen, and these are really wonderful large oil paintings, female figures that the artist produced. And Linda, of course, has been featured at the museum before, but she's a really wonderful artist. And then last but certainly not least, we have Uncommon Perspective, which is put on by Art Sherwin. Art Sherwin is a longtime educator and artist in our community, has a long-standing relationship with the Bakersfield Museum of Art, and he has some really wonderful paintings that he's done of both Bakersfield as well as the surrounding Kern area. So if you do get a chance, please check those out on our website. There's a virtual tour that you can take, and it's really awesome. Now, let's see. We also have Saturday Studio coming up. Saturday Studio, this coming one on the 20th. The deadline to register for that will be 9 a.m. tomorrow. That's Wednesday, the 16th. But there are classes after that you can still register for, but just so you know. But the Saturdays to You is a really great way to get some extra art education in on the weekends, and highly encourage that you check it out. Now, to talk a little bit about our project, we're going to be talking a little bit about symmetry. And Mary was talking to me that she knows a little bit about it. And would you say, what do you think of symmetry?
It's cool because like the two sides are exactly the same.
Yeah, exactly. So, I mean, if you look at this tree that we have on this graphic over here, you can see that on one of them, it's split down right down the middle, and both halves are going to match up. But then on the tree on the right, we have asymmetry, in which they split down the middle, they are not going to line up. So it's a little bit different. So symmetry you'll find in math, especially in like geometry. Are you taking geometry right now?
No, but I had it a little while ago.
You had a little while ago. Okay, and did you talk about symmetry in that class?
Yeah.
A little bit? Very cool. But in the art world, symmetry can be very important to artists because it can factor into their work. A lot of artists really like to have symmetry because symmetry is often found to be very beautiful. Now we also have symmetry that can get a little bit more complex. So if you were to take a shape like this, you could actually split it into several different ways and have all of those shapes still be symmetrical. As you can see, I mean, it's cut in half, it's cut into quarters, it's cut into, looks like, eighths or twelfths. And all of those shapes, if you were to take them separately, you can stack them on top of one another and they'd all match up. So that's one of the really cool things about symmetry. So what today we're going to do is we're actually going to do a little bit of no-tan artwork. Now, no-tan is a Japanese term that means kind of light and dark harmony from a design aspect. So have you ever seen like a yin-yang symbol?
Yeah.
Familiar with that? That's kind of like a no-tan design. It's a Japanese concept. And it's really kind of playing with space with light and dark shapes. So if we want to dive into this, what we're going to do is we just have just a few things here. We have a black piece of paper, a white half sheet of paper, a pencil, scissors, and some paste.
Okay.
And to start off with, we're going to want to take our pencil as well as our white piece of paper.
Okay.
And we're going to go ahead and we're going to start to draw a shape. And this can just be like a simple shape. I'm going to do a heart. And we want to draw it starting on the edge of our paper. And we can just kind of sketch it. And we make it kind of big because we're going to cut these out in just a moment too.
Oh, okay.
Yeah. And it doesn't need to be perfect. This is just practice after all. So do you want to go ahead and do yours?
Okay, so I guess I'll do a square.
Sure, yeah. Perfect. Now we can take our scissors and we can go ahead and cut out our shape real quick.
Okay.
Just be careful with our scissors here. All right, you got your square? Mm-hmm. Awesome. Okay, so now what we can do is we can take our half sheet of paper and we can lay that down on top of our black piece of paper.
Okay.
And then we can also just, just like this, to where it's a landscape.
Okay.
Yes, we want to turn this one. Go ahead and turn this 90 degrees.
Okay.
Like that. And there we go. And we can take that other shape and we can lay it just kind of like so that the edges are touching. You can see that? So now these shapes, apart from being inverted colors, would you say that they're symmetrical? Mm-hmm. Yeah, it's pretty cool. So that's kind of a simple no-tan design, but we can actually take it a step further. So we want to go ahead and take our shape and then go ahead and draw the same shape inside of your shape. So I'm just going to draw another heart inside, and you can do another square inside of your shape. Okay, and we can go ahead and cut that shape out.
Okay.
As carefully with our safety scissors. It's always great to come back to this program because I get to use all the really cool school tools that I haven't gotten to since elementary school. Mm-hmm. So now we have another shape. So then what we can do with these two pieces is we can go back and we can add them.
Okay.
and then you can put that other shape inside of, on the other side. So
Oh,
there-
okay.
Yeah, pretty cool, right?
Yeah.
Now we can continue to do this over and over again. We can put even different shapes inside and make this really cool two-sided symmetrical design. And that's kind of the essence of the no-tan design philosophy. Pretty cool, right?
Yeah.
Yeah. So now with our paste, we can just paste our shapes into place. And we just want to make sure that the edges are touching.
Okay. Oops.
Now, if you were to go online and look at different images of no-tan artwork, you can see how creative and amazing people get with their projects. I mean, there's people who do whole landscapes based off of this particular
Wow.
art form. But this is a really cool way, like if you like making greeting cards or anything like that,
Yeah.
it's a very cool and easy way to do something like that.
Cool. Okay. Last one.
I like her, she uses a lot of paste. Very thorough.
There we go.
Awesome. But you can see how you can get even more complex shapes and things like that the more detailed you want to cut your paper. Make sense?
Yeah.
Cool. Well, thank you so much for helping me do the math and making some cool artwork, and I really appreciate you guys bringing me on again. But please reach out and check out the bmoa.org website, take those virtual tours, and if you have any questions or anything, just let us know.
All right, thank you very much, Curtis. That was awesome because it's one of those things where you can tie math and art together. Symmetry is one that just naturally goes together. And once again, you have a Saturday workshop, I think you said, coming up, and tomorrow morning is the cutoff for that?
Correct. 9 a.m. is the cutoff to register for Saturday's studio class.
All right,
But then
and-
there are other Saturday studios that you can register for past that date.
All right, well, the website is up there once again, and thank you once again, Curtis, and thank you to the entire Bakersfield Museum of Art. And we'll be back with more right after this.
Well, hello! It looks like Elif, our friendly neighborhood naturalist, is enjoying a moment outside and obviously saying, "Hello, friends!" Ah, that looks like a journal in his hand. Are you looking for something to journal? Can I suggest something? How about something that is alive and crawls around? What about using a sow bug? You know, a roly-poly as your next journal prompt. Where could you find such a creature, you ask? Well, look under some rocks. Yeah, how about those? I like how careful Elif is being, lifting each rock so as not to crush anything underneath. Oh, I think he might have found something. A sow bug would be the perfect animal for Elif to use as his next journal prompt. Oh, and it looks like he has a container at the ready to carry the animal. Elif probably doesn't want the animal to fall or escape somewhere in his house while journaling. I know how squeamish he is around things that can crawl, and he doesn't want to hurt any animals that he might come across in the wild. Journaling an animal in its natural home or habitat is a great way to feel at peace outside and truly connect with nature. If those aren't options, then indoors will have to do.
always a plethora of ideas and things to learn at Camp Keep. And you remember some of that?
Yeah.
Were you able to do any Camp Keep activities this year? Does your school do that?
We did it virtual, so we
Okay,
watched
yes.
the
Well, everybody
videos.
has to this year.
Yeah.
What was one thing that you kind of remember from Camp Keep?
Well, I remember that the campfire songs for sure, and the journaling, I guess.
Yeah, there you go. Well, campfire songs were a big one. You remember scat?
Oh yeah.
Okay. Well, we'll just say that you remember it. And other kids that are like, what are you talking about? Well, you'll have to experience it for yourself. Anyway, we do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. Mary, a 6th grade student from Bimat Elementary, is in studio with us today. And the 3 M's up here, we're dealing with mean, median, and mode today, all right? That's your entire show, sister. So here's what I'd like you to do. I've got a challenge for you right now.
Okay.
All right, so either you or Marylou can write this up on the board. This is what you will have to accomplish.
I'll let you write it.
All right?
Okay. Go ahead.
So first, write mode is less than, so put the symbol for less than, median, less than the mean. So you have to find a set of 5 numbers where the mode is less than the median and the median is less than the mean, and this is only done with 5 numbers. So I want you two to come up with a set of 5 numbers and see if it works. And if not, try another set of 5 numbers, see where you have to modify to make this complete.
All right, Mary, so what's the first thing you're thinking?
I'm thinking that we should make the mode the smallest number.
Okay, go ahead and put up.
So I guess I'll do 1, and I'll put it 2 times.
Okay.
And then the median has to be a little bigger than that, so we could do, thinking of a number.
Remember, we're adding all these up, so.
Yeah, so we can do a 3.
Okay.
And the mean will be bigger than the median, so we could do I guess a 5 and a 0.
Okay, we can't do 0. Well, we could. We don't have to put them in order from least, or we do need to put them in order least
Right,
to greatest.
eventually you will.
Yes.
So if you want to, just
but if we
right around.
put a 0 in there, then your median is going to be 1.
Oh.
Do you see that? So
Yeah.
let's do a number bigger than 5.
Okay. How about 6?
Sounds perfect to me.
Okay.
So let's add those up.
Okay, so 1 and 2 is, 1 and 1 is 2, 3 and 5 is 8, and then 6 and 8 is 14. 14 and 2 is 16.
Okay, and we need to divide those by 5.
Yeah, so 16 divided by 5 is gonna be 3. 15, get a 1, bring down a 0, put a decimal. 10, 5 goes into 10 2 times, and you get 0.
So let's see if we did it correctly. What is our mode?
Our mode is 1.
Okay, and we know that that is smaller than the median, which is
3.
And which is smaller than our mean, which is
5 or 6.
Nope, what's our mean right here?
Oh, our mean is 3.2, sorry.
There you go. I think you just solved it.
Nicely
Wow.
done. All right, so you've got your feet wet with this now. All right? Erase the board, young lady.
Okay.
Here comes a problem specifically designed for you. All right?
Okay.
Median first. Is less than the mode, which is less than the mean.
Mean. Okay.
So let's put up our 5 lines again, okay? I'll let
Okay.
you go ahead and do that.
I'll do it red and red,
Okay.
so it's better. 1, 2, 3, 4, 5.
So what do we want the smallest?
The smallest is going to be the median, which is in the middle.
Okay,
So
so let's pick a number and put it in the middle.
it should be, I think 1 is good for that.
Okay, well, if that's a median, it has to be in the middle, right? So
Oh,
it has to
right,
be on the
okay.
3rd line,
Third line.
right there. Okay, so what should we, do you want to fill in the other 2? Remember, they have to be numbers less than 1. And they did not say that we can't use 0 or negative numbers or decimals. We can use all that.
Okay. I'm going to do 0.5. And also, I think I'll do 0.25.
Okay.
I think that's good.
So what other information do we have? So we have our median set in the middle. So we
Yeah.
know that our median has to be smaller than the mode.
So the mode can be,
We know it's got to be greater than 1,
how
correct?
about 2?
Okay. All right, so let's add those numbers up.
Okay. These 2 equals 0.75, and then 1 and 2 equals 3, and then 2 plus 3 is 5. 5, and then 5 and 0.75 is just 5.75.
And let's divide that by 5.
And then, yeah, divided by 5. Oh, wait, let me erase this. It's easier.
Before we divide that by 5, okay, we know that the mean has to be greater than the mode, right?
Yeah.
How many times does 5 go into 5?
5 goes into 5 once.
Whoa, 1 time. What's our mode?
Our mode is 1.
No, our mode is what?
Our mode is 2, sorry.
Right off the get-go, is our mean going to be smaller than the mode?
Yes.
It is. So what can we do to the mode? Because we know that our number, when we're looking at our mean, it's going to be a number smaller than 2, obviously, right?
I have an idea.
So what's your idea?
I think I'll erase this and this and change this into a 1. So then it could be the mode.
But yeah, why
okay.
is that not going to work?
Because it has to be smaller. So
Yeah, the median has to be smaller than the mode, right?
I have another idea.
Okay.
How about put 0.5 here and 1 over here?
But
Oh,
now our mode is smaller than the median.
okay. This
I
is
like your
hard.
0.5.
Oh,
Can
okay.
we change the other 5/10?
Let me erase this and fix it. Yeah, I think so.
Okay.
We could do this 0.5, and this is a 1, and then erase this, or make this into a 0.25, and then this is something else.
Okay.
We'll make this over here, let me see.
What about 0? Can we leave it at 0?
Oh yeah, we can do a 0.
Okay.
Yeah.
But we need to change the other 2 to a 1.
Oh wait, let me erase this real quickly. Yeah. So we could,
Let's change this right here. Make that a 1 as
Yeah.
well. Because we need a mode, and right now we don't have a mode.
Okay, so 1.
Okay, so now we have,
So our median is 0.5, our mode is 1, and our mean is, let me see.
well, there's,
So-
what, is that 2 and 7/500ths? Yes?
This is 0.25, yeah.
Yes, and then plus another 50. Think of it as money. You
Yeah.
have 50 cents, you have 25 cents, and I have
75.
2 $1 bills.
And then 2.75.
There you go. I always look at decimal as money.
Yeah, me too.
Okay, now we have to divide that by 5.
Yeah, so here, let me write it over here. Oh, oops. 275 divided by 5. Wait, we can't do that.
Well, we can. Bring the
where we get
decimal
the
straight
decimal.
up, right?
Oh yeah, right. So the decimal straight up, and 5 goes into 2.
Well, does 5 go into 2 at all?
No.
0 times. Put a 0 there for me for a second.
Okay.
So again, is this going to work? Because our whole number is 0, and we know that it has to be greater than 1.
Oh, no,
That's not going to work, is it?
no. Oh wait.
Well,
oops.
might as well, yeah. Let's think of something different. Let's try this. Let's put the 2 1s, make them 51 cents.
Okay. 51.
Let's see what happens here.
Okay.
And let's add those up.
Okay, so this is 75. Oops. So 0.75.
And then let's think about this. You have 50 cents and 50 cents, which is
$1
plus-
and 2 cents.
right.
So 1.2.
0.2.
Or 0.2, sorry. Oh,
So if I have 75 cents
yeah.
and I add 2 cents to 75 cents, how much do I have?
You're going to have 77 cents, and you would get
And
1.77.
perfect.
7, yeah.
1.77. So that's what our total is. So let's divide that by 5 and see where we're at.
Okay, so, oh, whoops. So, okay, so 5, and it wouldn't go in, so you would put a 0, bring up the decimal, then 0 times 5 is 0, subtract, you would get 1, bring down the 7. 5 goes into 17 3 times.
And we can stop
Yeah.
right there, right?
Yes, we can,
So,
because
Mary, what I'd like you to understand is that not every math problem can be solved quickly.
yes.
Some are challenges and will take a little while, but I want to ask you this. Did you have fun today?
Yes.
Excellent. That's what I wanted to hear. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.